Hello. If we have a right angle triangle and we know one of the acute angles and one of the side lengths, then we can calculate the other acute angle and the other two side lengths. We can do this using this mnemonic here. Now, before we start, this should be explained. S is equal to the sine. O is equal to the opposite angle. H is equal to the hypotenuse. A is equal to the adjacent angle. C is equal to the cosine. And T is equal to the tangent. Now, we need to break this mnemonic into three parts. SOHCAHTOA. So we have SOH, CAH, and TOA. This is sine equals opposite over hypotenuse. CAH becomes the cosine of the adjacent over the hypotenuse, and TOA becomes the tangent of the opposite over the adjacent. If we have an angle here, let's say it's 30 degrees, then this is the opposite, this is the adjacent, and this is the hypotenuse, of course. Let's say we know the adjacent. The adjacent is 6 units. So what information do we have that we can put into one of these equations so we can get another value out? Well, we have an angle and a side length adjacent to that angle. Remember, this is the one opposite, this is the adjacent. So we have an angle and an adjacent, so we would use this one here. Okay? So the cosine of 30 degrees is equal to 6 divided by the hypotenuse. Therefore, the hypotenuse is equal to 6 divided by cosine of 30 degrees, which is equal to 4 root 3, which is 6.9 to 1 decimal place. From this information, because we have the angle and the adjacent, we can also find the opposite value. So the tangent of 30 degrees is equal to the opposite side divided by 6. So the opposite side length is equal to 6 tan 30 degrees, which is equal to 2 root 3, which is equal to 3.5 to 1 decimal place. So we know this side length is 2 root 3. Now we can find this angle here, because we have these side length. Let's call this angle theta. Because we know these side lengths, the opposite side length and the adjacent side length, we can also use the tan here too. So the tan of angle theta is equal to 6 divided by 2 root 3, which means theta is equal to the inverse tan or arctan of 6 divided by 2 root 3, which is equal to 60 degrees. Very nice. Let's do another one. Now let's say we have this angle here and it's 27 degrees, and we want to solve all side lengths of this angle, of this triangle. We know this side length is 6, and we need to know this side length, and this angle theta. To begin with, we have one angle and the opposite side length, so we could use this part here. So we'll say the sine of 27 degrees is equal to the opposite, which is 6, divided by the hypotenuse, which here is y. So we'll call that y. So y is equal to 6 divided by the sine of 27 degrees, which is equal to 13.2 to 1 decimal place. So this is 13.2. Now let's have a look at side length x. Now we know the angle and the hypotenuse. We could use this one here, cosine of the angle, and we have the hypotenuse. We just need to solve for the adjacent, which is x. So here we have the cosine of 27 degrees is equal to x divided by 13.2. So x is equal to 13.2 cosine of 27 degrees, which is equal to 11.8 to 1 decimal place. Now, I didn't use the full calculator precision here. The real answer was 13.1 something something something. In your exams, use the full calculator precision. Otherwise, you will propagate errors through, and this may be 0.1 off, and you'll lose a mark for it. So be careful with that. So now we know this is 11.8. We can calculate this final angle theta. We can use any of these now because we just need an angle. We have all of the side lengths. So let's just choose sine. The sine of theta is equal to the opposite of theta, which is 11.8, divided by the hypotenuse, 13.2. So theta is equal to the inverse sine, or the arc sine, of 11.8 divided by 13.2, which is equal to 63.4 degrees to 1 decimal place. And there we have it. That's how to use trigonometry. If you enjoyed this video, then feel free to subscribe, like, share, comment. Have a nice day.